Zeal Education Society, redefining excellence.
Now let us see the magnetic field produced by or magnetic field due to current carrying conductor. Magnetic field due to current carrying conductor. Now let us assume that the conductor carries the upward current. Say this is the conductor and it carries the conductor in upward direction. So what is the direction of magnetic field produced? The direction of magnetic field produced is counterclockwise, that is anti-clockwise, and it is denoted by dot. That is, it is coming towards the observer. It is coming towards the observer, and so it is just like an arrow coming towards the observer. So we can observe the tip of the arrow, and hence the dot is presented. It is represented by the dot. So the direction of magnetic field is counterclockwise. Okay. Now let us say the conductor is carrying the current in downward direction. Say this is the direction of the current. Then the magnetic field produced, direction of magnetic field produced is clockwise. Say this is clockwise. And this is denoted by cross. This is denoted by cross. So what we can say, when the conductor carries the current, it produces the magnetic field around it. So let us write here, when the conductor or when the current flows through the conductor, flows through the conductor, it produces magnetic field around it. The direction of magnetic field depends on direction of current flowing through the conductor. And this can be obtained by using the right hand gripping rule. But before that, let us show the magnetic field. See, this is the dot, indicates that it is an upward current. So for the upward current, the direction of magnetic field is counterclockwise. So here it is, or we can say dot upward current. The direction of magnetic field is CCW. So the direction of magnetic field is counterclockwise. Now similarly we can show for the cross convention. Cross is somewhat going away from the observer inside the plane. The current going inside the plane or going away from the observer or a downward current. Cross represent downward current or the current going away from the observer, just like a arrow going away from the observer. You can observe its arrow. It will just like a bird coming towards you with its feathers. So it just like seen as a cross, and therefore this cross can be shown as, this is the cross, and the direction of magnetic field is clockwise. Downward current. The direction of magnetic field is direction of field is direction of magnetic field is clockwise. Or this is the downward current or current going away from the observer. So the direction of magnetic field can be obtained from the right hand gripping rule. So right hand gripping rule. Let us grip a conductor in your right hand. See, as shown in this figure, grip a conductor in your right hand in a such a way that thumb stretched along the direction of current. Say, we are observing for say upward current. Thumb stretched along the direction of current. Then the cold fingers gives you the direction of magnetic field. See, in this case, the direction of magnetic field, that is the direction of curled finger, is counterclockwise. And same is shown here also. See, the thumb points the direction of current. Thumb points the direction of current, and the curled fingers, these fingers, gives the direction of magnetic field. So the direction of magnetic field is counterclockwise. It is CCW. Whereas grip a conductor in your right hand such a way that thumb stretched along the direction of current. Say let us consider the downward direction of current. Downward direction of current, the curled fingers give the direction of magnetic field. So the thumb direction of current and the curled finger direction of magnetic field. So it is a clockwise. So this is clockwise. So this is the right hand gripping rule. So let us write here, grip a conductor in your right hand in a such a way that thumb stretched along the direction of current. Then CURLED, curled fingers, gives direction of magnetic field. So, the direction of magnetic field can be obtained from the right hand gripping rule. You can apply for the downward direction as well clockwise direction. Now, this can also be obtained. From the corkscrew rule. Corkscrew rule. Say, when fitting the screw in a batten or a wooden board, when fitting the screw in batten or a wooden board, the direction of rotation of the screw gives the direction of magnetic field. Direction of rotation of the screw by the screwdriver gives the direction of magnetic field, and the advancement of the screw is going inside the wooden board. That is the direction of going indicates the direction of current. So this is a wooden board. So the direction of going into the wooden board is the direction of current. and that means in this case, say it is a downward direction of the current, and the direction of magnetic field is here clockwise. Direction of magnetic field is clockwise here. Let us remove the screw. Let us remove the screw. While removing the screw, we have to rotate the screw by means of screwdriver in a counterclockwise direction, anti-clockwise direction. So this anti-clockwise direction of movement of the screw by the screwdriver indicates the direction of magnetic field. And what will be the movement of the screw now? We are removing the screw, so the movement of the screw will be upward. Movement of the screw will be upward, and the direction of the rotation would be CCW. So in this way, the corkscrew rule, this is cork, C-O-R-C-K. This is the corkscrew rule. So in this way, we have learned the magnetic field due to current carrying conductor. When the conductor carries the current, it produces the magnetic field around it, and the direction of magnetic field is given by the either right hand gripping rule. It is also given by the corkscrew rule, and when for the upward current the symbol used is dot, or for the downward current symbol used is cross. Cross is just like a feather of the bird flying, and the dot is somehow the arrow coming towards you, or the cross arrow going away from you. So the upward current, the current coming toward the observer, and downward current going away from the observer. So we have finished this part, and now let us see the magnetic field strength due to long straight conductor. Magnetic field strength due to long straight conductor H. Now let us assume that a group of conductors is just like a cable. Cable contains 4 conductors or many conductors in standard form. So, and they direct the current in either downward or upward direction. So let us consider the cross. Say these are the 4 conductors. Say these are the n number of conductors, and we have to find out the field strength at a distance r from the center. Say this is the point A. So what will be the direction of magnetic field produced by this downward current? So it will be clockwise. So let us draw the clockwise direction of the magnetic field. See, the field strength at point A outside the conductors at a distance r meter from the center of the conductor is given by the Works rule, or the MMF equal to magnetizing force H into distance. Actually, this distance is nothing but this is nothing but a force. Magnetizing force into distance is nothing but work done, and that's why it is known as work law or a work rule. So when this force is moved against the direction of magnetic field and completes the closed path, complete round, The work done is nothing but force into displacement, and therefore here MMF is nothing but N into I equal to MMF is nothing but N into I which equal to H into distance is 2 pi r. This is the complete round around the conductor, that is nothing but 2 pi r, and therefore magnetizing force H equal to Ni upon 2 pi r, ampere per meter or AT per meter. So this is the magnetic field produced by, or this is the magnetic field strength produced by long straight conductor, long straight current carrying conductor, OBS, long straight current carrying conductor. So in this way, we have finished here the magnetic field due to the current carrying conductor, the dot convention, cross convention, the right hand gripping rule, corkscrew rule, and magnetic field strength due to the long straight conductor.